Okay, we're going to look at imaginary numbers, and we're going to recall some stuff that we learned from Algebra 2, and then move a little bit further in that understanding for honors pre-calculus. So we're looking at complex numbers. So if you think back, some stuff that I think you learned in Algebra 2, a complex number is in the form a plus bi, where you have a real part and you have an imaginary part. Some examples would be of complex numbers would be 3 plus 4i, negative 7 plus 2i. 3 is a complex number. 2i is a complex number. It doesn't have to have both parts. So all numbers are complex numbers. But the ones that, when I say a complex number, I'm kind of thinking about the kind with an imaginary part as well. So if we were to look at sets of numbers, it's like using a diagram. This would be our set of complex numbers. Let me write it in here, complex. Then inside of that, we would have, like, say, real numbers. Inside of reals, we would have, I'll just stop here and just kind of say, we would have like rational and irrational is one way to break it down. I know it's hard to see that, but so complex numbers that are not real numbers are like 2 plus 3i. Then you have real numbers that are like 4 or square root of 7. Those are real numbers. Sorry, I said 4 and I wrote 3. 4 and square root of 7. Those are considered reals. And if I were to put those in their circle, it would be like this would be the rational and this would be the irrational. So I'm just showing you that complex contains the reals. We're just adding in this imaginary, this imaginary part. Okay? So that's complex number. And here's an example. So you learned that in Algebra 2 Honors, but I want to extend your thinking, and we're going to learn a little bit more about them and try to learn about them intuitively. I think what you do in Algebra 2 Honors, which is how we do it, we first just introduce you to the numbers and do operations. You learn that I squared equals -1. So then you start to deal with numbers like I cubed and I to the 4th, and you can figure out what those are. I'm not going to rehash all of that. Then you do operations. So you work on, like, what if I had 4 plus 3i and I wanted to add to it 2 minus 7i, right? You would work with that. What if I had 4 plus 3i, this complex number, and I want to multiply it by 2 minus 7i, right? Those are some of the things that you worked on doing. We're going to try to give a complex number some meaning mathematically, like another intuitive meaning, and a visual representation as well, like graphically what's going on. So I'm just going to introduce that to you here today. So since this is a number line of all real numbers, so again, we have numbers on here like 0, like 4, like, I don't know, maybe it would be right there, I don't know, 5 halves. We have numbers like pi on there. These are all real numbers, rational and irrational. We have the negative square root of 5 on there. And be clear that that's a negative. All those numbers are on this real number line. But where does 4i show up? Or even more crazily, where does like 2 plus 3i show up? Well, these numbers do not exist on this real number line because that would just be the real numbers. These type of numbers are outside of the reals, okay? So how do we deal with that? Well, we need another axis. We're going to make another kind of dimension on this number line. We're going to make a 2-dimensional number line. So we're going to make another number line that goes this way, so we can show what a mixture of these two types of numbers are. Now, this would be 0 on the number line that's going vertically, and they're going to cross at 0, 0. So these kind of meet up at 0, 0. This number line will be the imaginary number line. So if I wanted to graph 4i on it, I would go up 4 units, And that point right there would represent 4i, okay? So that point would be the complex number, or the imaginary number 4i. This point here would just be the real number 4. And if I want a mixture like 4 plus 3i, well, remember, this is the real part. This is the imaginary part. So I'm going to go over 4 units on the real, and then up 3 on the imaginary, and that would be the number 4 plus 3i. So instead of graphing numbers on a number line, we have to graph them on a 2-dimensional plane, where one dimension is the real numbers, and the other dimension is the imaginary numbers. So this is called the complex number plane. All right. The complex number plane, it's like a number line. When I say I have a real number line or a number line for integers, it's the same idea, but a number line doesn't get it done for complex because we have these 2 different dimensions, these 2 parts, and one of the parts, the imaginary part, is not, it doesn't live on the real number line. So I have to actually make a number plane. So when I say number plane, you can think it's like a number line, but it's like, you know, a beefed up number line. It's got a second dimension. I know you're thinking like, this doesn't make sense. Where does this make sense in the real world? Because I have an art teacher standing in my doorway, and he's thinking the same thing. So, but I would just propose to you that negative numbers were crazy and didn't seem to have meaning to people at one time. But that didn't stop mathematicians from looking at them, right? Like, people didn't know what having negative 2 cows meant. But later over time, so negative numbers maybe were developed, and then over time we figured out how they can be represented in the real world. I will tell you the same thing is true of imaginary numbers and complex numbers. It seems weird right now, but there is a application, and we can make some meaning out of this visualization. I don't want to get into that in this video. This was just supposed to be an introduction to the complex number plane and to remind you of some of the things that you've already learned about complex numbers. Thank you. Have a great day.